This is a challenge problem for solving equations with exponential functions. I quite like this problem. I think it's a really good challenge. It's very difficult, gives a lot of students trouble, but I think the answer is very obtainable if you just stick to your principles and are very disciplined with all of the choices you make. Um, I have a very unique way of solving this. I am going to first attempt to do it the right way, or at least what I would expect the textbook would want, and then I will show you my solution, which is a little interesting, and we'll get into that in a minute. So first thing we might want to do is let's just take the logarithm of both sides, and I'll just choose a random base. We just want to get rid of one exponent somewhere. So let's take the log of base 7 of both sides. And so let's see what we're going to end up with. Well, this log and this base will cancel. And so I'm left with 3 plus 7x equals log base 7, 3, 4 minus 2x. Now, I'm going to take advantage of the power rule, and I'm going to move the expression in that exponent down in front of the logarithm. So on the right-hand side, I'm going to get 4 minus 2x times the logarithm base 7 of 3. And so at this point, the place where this problem gets kind of tricky is you need to get used to the thought process of thinking about your logarithms that are free from variables. So for example, this logarithmic expression, free of any variable, that is just a constant term. I can treat it like a constant term. And so we have to be very careful with our algebra, but everything should work out just fine if I am careful. So the first thing I'm going to do is I'm actually going to distribute this value, log base 7 of 3, into 4 minus 2x. So this is going to get me 4 times log 7 of 3 minus 2x times log 7 of 3. And actually, I'm going to change the way I write this. This might look interesting, but to try and express that that logarithm is still just a constant that I'm kind of like multiplying together, I'm going to write 2 log 7 base 3 and then that times x to really, send home the idea that that is just some coefficient of x. Again, it's really hard to express in decimal form, but that is just a coefficient. Okay. And then this was all being compared to 3 plus 7x. Okay. Now I'm going to combine my like terms. Well, I lied. I'm not going to do that yet. Let's move all the terms with an x to one side. Let's move all the terms without an x to the other side. So let's put 7x plus 2 log 7 of 3 times x. And then on the right side, we're going to have 4 log 7 of 3 minus 3. So all I did there was I subtracted a 3 from one side and I added that quantity of 2 log base 7, 3 of x. Okay. At this point, it might start becoming more clear what we're trying to accomplish. But what we're going to do at this point is I can factor out an x from this expression. So I might just scroll down a little bit here. But I can factor out an x, 7 plus 2 log 7 of 3. And then that's equal to 4 log 7 of 3 minus 3. Okay, now let's see where we can take this. Well, we can divide both sides by this whole quantity right here. That's a really bad brace, but can divide this quantity by both sides to isolate the x and have it all compared to one side. And so let's see, I will get x equals, and I might need some room here, it's going to have a nice sizable denominator, 4 log 7 of 3 minus 3. And then this will be 7 plus 2 log 7 of 3. At this point, this is technically a final answer. I have x isolated. I have a whole bunch of information on the other side. Again, if I had access to a calculator or a computer, I could enter this into a calculator and it would give me a finite value. Um, let's try and simplify this. This might get out of control like really, really quickly, but let's try and do it. I'm going to try and convert everything to natural base, but please bear with me. This is like, you know, this is a tricky part of the problem. I really hope I don't get it wrong. Um, but let's see where this takes us. So, first things first, I'm going to get 4 times. Now let's convert this logarithm to natural base. I'm going to get natural log of 3 divided by the natural log of 7, and then all of that is minus 3. Then I'm going to get, and let me redraw my denominator, then I'm going to get 7 plus 2, and this is times the natural log of 3 over the natural log of 7. Okay, so let's, well, I'm going to be running out of room here. Okay, let me scroll down, and I'm going to move this guy to a new line so I have space to work with. Okay, now let's take this quantity 4 right here and the 2 right here. Let's move those into the actual logarithmic expressions. So again, nice large denominator. I'm going to get, 4 times the natural log of 3 over the natural log of 7 minus 3. 7 plus 2 natural log 3 natural log 7. Okay. We can keep going. We can keep going. Now we want to well, okay. I mean, I'll be honest. I did not solve this going into this. This is all just kind of off the top of my head. Um, let's convert that 3 into that 7. Let's convert those into a common denominator that we can work with. So my common denominator I want here is log of 7. So I'm going to multiply 3 by natural log 7, and then that'll allow me to do some good work. And I'm going to multiply 7 by natural log 7 over natural log 7. And if you can keep that in mind, I'm going to delete it just so I have room. This is going to give me 4 natural log 3 over natural log 7 minus 3 natural log 7 over natural log 7. Then I'm going to get 7 natural log 7 over natural log 7 and 2 natural log 3 over natural log 7. If I don't wake up in the middle of the night chanting natural log, you'll know that I did something wrong with this problem. But okay, let's try. I want to make sure my 3's and my 7's are very distinct so I can keep track of them. Okay, let's start another line once again, just so I have space. We'll bring this down here. Okay. Now, let's combine everything, all the numerator individually, the denominator, convert each of those expressions to having under one large denominator. So this is getting, we're getting towards the final act of this problem. I'll have a denominator up here, 4 natural log 3 minus 3 natural log 7 over natural log 7. Again, I'm just subtracting across denominators, or numerators, I'm sorry. And then I have 7 natural log 7 plus 2 natural log 3 over natural log of 7. Okay. Now let's see where this takes us. Well, we can use the idea that if I'm dividing by a fraction, I'm multiplying by the reciprocal. So what this will actually look like is it'll look like 4 natural log 3 minus 3 natural log 7 over natural log 7 times, and then I take the reciprocal of my denominator, natural log 7 over 7 natural log 7, I need a larger fraction bar, plus 2 natural log 3. Now I can cancel these natural log 7s, and the final answer, which painstakingly, and again, this is why, the problem in itself is tough. The simplification is even tougher. This should be our final answer. I will put a red box around it so we can distinguish it. But we will get 4 natural log 3 minus natural. Yeah, I'm not even going to read that. It's on screen. I've said natural log enough times. It's there, right? But that is a way to simplify the answer. So again, I don't necessarily know what professors are going to be looking for. I feel like I would accept this right here as a perfectly acceptable answer. Again, you've isolated x, but you never know what they're going to ask for, and if you're asked to convert to the natural base, you might need to do a process that looks like that. Okay, now if you remember, I promised I would show you my way of doing the problem, at least when I first came across this problem, when I first started teaching pre-calc. The way that I did it, you know, do not expect this is something you need to do in your in your own time. This is quite a ridiculous solution, but I think it's very funny because if I do it correctly, it should give me the same answer, and then I guess I can be more confident that um, I'm right. So I don't actually know, how do I paste something? Okay. I don't know how to copy and paste, so I will just need to take this guy and move this um, down to a new line. Okay. So we're going to try and solve the problem again using an alternate method. I'm going to do this in green just to establish that I'm doing it differently. Okay, so the first thing that I did is I utilized um, the exponent rules. So I turned 7 to the power of 3 plus 7x into 7 to the 3 times 7, 7 to the x. Okay, then I can turn this into a division problem, 3 to the 4th over 3 to the 2x. These are just applying exponential rules, not super complicated. There's a theorem about them. Now what I did is I want to combine my like terms. So I want to move things that have a same base. I want to get my x's together, my non-x's together. I guess that's what I'm trying to say. So I can multiply over my x term, and I can divide over my non-x term. Okay. Now I need to recall where I got this. Oh, okay. I do. Yes, it is coming back to me. My method is coming back to me. All right. I hope you are ready for the most egregious move in pre-calc you've ever seen. Um, what I'm going to do is I'm going to take advantage of the fact that this expression here, I can use the power rule for exponents on my x variable to take out that x variable and raise it over the power of this whole quantity. So that'll get me 7 to the 7th times 3 to the 2nd, excuse me, and then all of that is raised to the power of x. So again, I'm just applying my power, my exponent rules. Um, so that looks very interesting. Um, here's what I would do. I would say, and again, I'm laughing at myself because I can't believe this is the direction I took this problem. Pause now and try and guess if you can see what I'm going to do next. It's horrible. It's ugly. I don't recommend it. Um, what I'm going to do is we're still going to take advantage of that formula I gave you. Sorry, I'm getting my videos mixed up. Um, I'm going to undo my logarithm with this property, that log base b of b to the x equals x. And I'm going to do that on the left-hand side of this equation. So look at what is about to go down. I'm going to have to make a lot of space here. I'm going to take the logarithm of base 7 to the 7 times 3 to the 2. That is going to be my base in this scenario. And the quantity, well, okay, so I should be specific. The one side of the equation is 7 to the 7, 3 to the 2 to the power of x. So that is one side of my equation. The other side of the equation, which I almost don't have room to even write, is log base 7 to the 7, 3 to the 2, of 3 to the 4th over 7 to the 3rd. And so I know this is a lot to keep track of, but if you'll notice, this equation I have right here, I have base b, just like I do in this problem. So the left-hand side of my equation is going to reduce to x, and the right-hand side of the equation is going to be log, that's kind of ugly, let me rewrite that, log base 7 to the 7, 3 to the 2, 3 to the 4 divided by 7 to the 3. And again, right now we've gotten to the same point right here in this red circle. I've isolated x. I have an individual thing that I can type into my calculator It might be very ugly to type that into your calculator because of the complicated base, but I can put that into like a website or something, and that would compute the value of x. So let's try and make this look like the red box answer I have written right here. Let's actually simplify this and put this into a nice looking form. Well, you might be able to see what's going to happen. I guess a good exercise would be try and convert my expression to natural base and see that you get the same thing. But let's look at what's going to happen here. So I'm going to get, well, x equals, the first step to converting to natural base is I can take the natural log of the quantity divided by the natural log of the base. And at this point, we're just going to use logarithm rules to expand this expression. So in the top, I have a division. That turns into subtraction. So I get natural log of 3 to the 4th minus natural log 7 to the 3rd. On the bottom, I get natural log 7 to the 7th plus natural log 3 to the 2. Now I'm just applying power rules. Now I get 4, I don't need a parenthesis there, 4 natural log 3 minus 3 natural log 7 over 7 natural log 7 plus 2 natural log 3. And if I did everything correct, this should be the exact same thing that I have written here, showing you that both methods work and that my answer, oh shoot, I gotta make sure I don't lose the selection. There we go. And we should see that I get 4 natural log 3 minus 3 natural log, oh no! I messed up! What did I do? So I got something wrong. Okay, that's all right. I made a mistake somewhere. Yes, I see it. So I interpreted, and this is good. Hopefully, you watching along at home have caught this. I interpreted this 7 right here as a 4 right here. That is not correct. So this right here, this guy should be a 7. And I guess it's good that I checked my work using another method. I should scroll over so you can see. But yes, I misinterpreted my handwriting. I thought that 7 was a 4. Hopefully you guys, the viewer, caught that the whole time. But yes, as you can see, both methods, and I should really stress that that is a 7 as well, both methods led to the exact same answer. So I think this is a really, really nice problem. It really expresses how you can be very creative when coming up with these solutions. You can attack it from many different angles. I love this problem. I'm sorry that I made that mistake. I am not re-recording the 17-minute video, I can tell you that much. But yeah, I think this is a really nice problem, really great one to study. Probably a little more difficult than what you would see on an exam, but I can't make any promises. Anyway, that is the challenge problem solved for this section. Thank you.